the single phase bridge rectifier circuit for the application conversion of alternating current to direct current DC power. Here you can see the flow of the power from the source to the transformer, which is to step down or step up the power to the required voltage and current. And once you achieve the alternating current of the required voltage and the current, you have to change it to DC power, which is the direct current and the voltage, which is used by the device or the equipment used in our home or office. So in between AC to DC, the conversion takes place at a device which is known as the rectifier. So the rectifier is actually consists of some power electronic devices such as diode or thyristor, etc. So in this circuit, we are actually going to understand the function of a rectifier with help of a 4-diode system, which is also known as bridge rectifier. So here the construction of the rectifier based on the arrangement of the diodes is actually looks like a network bridge. Hence the name is suggested as bridge rectifier. And this rectifier circuit is to convert a single phase alternating current to the direct current. Hence it is also known as single phase rectifier. So let us go to the circuit and understand the function of this rectifier and also the characteristics of the input power, the waveform, and the output waveform. So here the input is alternating current. So we have the positive potential and also the negative potential. So when you have the alternating current from the power source, the required voltage is step down or step up from the source. So let's say, for example, the source has 600 volt AC power supply, and you cannot directly use the 600 volt to the device. Therefore, we have to step down to the smaller voltage, for example, 240 volt or 120 volt. And there is also another characteristic of a AC power, which is the frequency. Some countries, they use 60 hertz, and some countries, they use 50 hertz. So frequency is the number of times you have the positive and the negative potential in 1 second. So that's the frequency. And you have the voltage and the current. So you have the maximum voltage and the minimum voltage as 0. So the potential between 0 voltage and the maximum voltage may be 240 or 120, depending upon the transformer rating. So the transformer, let's say, for example, you have 600 volt, and then you're stepping down to 240. So there is actually a step down transformer from 600 volt to 240. So the transformer ratio is 240 over 600. Okay. Once after conversion of the AC power from high voltage to the required voltage, then we need to convert to the DC power, the DC current, for the utility of the device. So here the device is, let's say, for example, a fan or an LED, which operates with the help of a direct current with a voltage of, let's say, 20 volt, and the current may be few amperes, let's say 0.5 amperes. So depending upon the device, the power output, you will have the voltage and the current. So let's say the rectifier is converting this 240 volt to 20 volt. So you need to reduce this voltage and in the direct current form. So you have the input voltage, which is in the form of a wave, which is a sinusoidal wave, which ranges from 0 volt to 240, and then again 240 to 0 is the positive potential. the current flow in the positive direction or maybe in the clockwise direction. In the negative potential, you have the current flow in the reverse direction. So the current flows from 0 potential to minus 240. Here the minus 240 is indicating the direction. So here you have the minus 240. So the current is actually reverse. So in alternating current, one half of the cycle you'll have the current flow in clockwise direction, and the second part of the wave, that is the second negative cycle, will have the counterclockwise direction. So you have both clockwise and anti-clockwise direction at a phase difference of 180 degree between the cycles, between the half cycles. So one full cycle is 360 degree. So after completing one full cycle, the second cycle starts. So you will have about 50 cycles per second or 60 cycles per second, depending upon the frequency of the power supply. Okay, that's on the alternating current side, which is the AC power. On the other side, we have direct current. So the direct current supposed to be only on one positive or the negative. Either the current should be in only one direction, either from clockwise direction or anti-clockwise direction, either from left to right or right to left. So that's the direct current side, means on the direct power side. So you don't have any negative or the negative cycle in the direct current. So you'll have only one direction flow. So this rectifier circuit can convert the alternating current into a direct current, means it converts the flow of current in bidirection, means for the forward direction and the reverse direction, to only one direction, maybe forward direction or maybe reverse direction, depending upon the design of the rectifier. Okay, now let's go to this rectifier circuit. So let's see the arrangement of the diodes. So we have 4 diodes. So let's say we have D1, D2, D3, and D4. Or just for a better understanding, let us rearrange in D1, D2, and for the negative cycle, we have D3 and D4. So let's say during the positive cycle of the alternating current, so this is the alternating current, let's say 240 volt. After the step down from the main power source of 600 volt, the transformer step down to 240 volt, and 240 volt power is actually supplied and alternating current. So the first part of the cycle, let's say the positive cycle is in this direction, let's say from the point A to point B, and from B to point C, and from C to point D, E, and F. So the current flows in the direction A, B, C, D, E, F. During the negative part of the cycle, the current reverses in the opposite direction. So the current from F, E goes to the B, C, G, A, and then it completes the second part of the cycle. So every time you have one half cycle pass the current flowing through diode D1 and D2. During the reversal of the current in the alternating current, the current flows in the opposite direction. It passes through the diode D3 and D4, whereas the D1 and D2, it prevents the current entering into the diode because of the function of the diode. So the diode is supposed to pass the current only in one direction. The direction is decided based on the positive and the negative potential. So when the diode is positive on one of the anode and the negative potential on the cathode side, the current will flow through it. Suppose if the potential is higher on the cathode side and lower on the anode side, the diode will not allow the current to flow through it. So this is the characteristic of a diode. So we are utilizing the diode function to perform the circuit operation to convert the alternating current to a direct current. So here between B and C, the point B and C is actually exhibiting a direct current. So whatever may be the cycle of the alternating current, maybe it's a positive or negative, the current flow through the resistor between B and C is going to be in only one direction. Therefore, it is considered as direct current. So the alternating current input, so this is the input and the output is here. Between B and C, you get the output voltage, which is actually in direct current form. And the current is designated as ID, which is known as the rectified current. And the voltage between B and C is actually known as the rectified voltage. So voltage VD. So ultimately, the current and voltage are actually changed from alternating type to direct current type. So the function of the rectifier circuit is actually to make the alternating current to the direct current form. So this is the principle of operation of a rectifier circuit. So this is because of the single phase power supply. It is known as single phase bridge rectifier. And sometimes you may have three-phase power supply. In that case, you need to change the design of the circuit with help of more the diodes, and then you can make three-phase bridge rectifier. So here we are focusing only on the single phase rectifier. Okay. Now here the output waveform is actually from 0 to maximum, maximum to 0, and 0 to minus the negative direction to the maximum voltage, and then again back to 0. So this is actually called as a full wave. And the rectified voltage is also a full wave from 0 to maximum, and then maximum to 0, and 0 to maximum, and it goes on. So the rectified voltage and the current, if you see, it is actually from 0 to maximum, maximum to 0. So the ripple is actually 100%. So the device may not be functioning properly. So we cannot operate any device with this type of a full wave rectified output. Therefore, we have to filter this output into a stable output form, which is actually something like this on the positive direction. Therefore, we need to change the output with help of a filter. A filter is again a device which can make the output in a stable form. So let's say, for example, you're making the circuit with an inductor attached to a resistor. So resistor is the load and the inductor is the filter. So inductor, the principle of the inductor, we know already. The electric current, when passing through a coil, it exhibits the magnetic energy. So the magnetic energy is actually inbuilt into the circuit. And then you can utilize this energy to stabilize the output power. Another example, instead of the inductor, you can also have a capacitor. So if you attach the capacitor parallel to the resistor, again, the function of the capacitor is to store the electrical charges, and then it will deliver into the circuit, the output circuit, in order to stabilize the output. So you can have two types of filters. One is inductive filter, the other one is the capacitive filter. So in the lecture notes, you may find the details about the inductive filter and capacitive filter and how to calculate what is the output voltage, that is a rectified voltage, and the rectified current with help of the formula for inductive filter and the capacitive filter. So the role of the inductor and the capacitor is to stabilize the output voltage and the current. So instead of having 100% ripple, the output voltage will be in the form of a ripple percentage 10 to 15%. So the ripple will be in the form of 10 to 15%. So that is the function of a filter circuit. So the rectifier circuit, basically operates with help of a 4 diodes to convert the alternating current to a direct current. And you can include an inductor or a capacitor to modify the circuit so that the output power can be stabilized into a uniform and stable power output. The voltage will be stable and the current also will be stable. Hence, the device can be functioning without any problem. So that's the principle of a bridge rectifier, and the problems related to this particular topic we will deal in the class. Thank you.